Hello guys, welcome to my channel. So today we will be discussing traversing of a synced linked list using Java. So we can say like it's link, linked list traversing, and we will understand uh, from the basics. So I mean previously what we have done. So we have created a few nodes. We have linked them, and we have defined the linked list properties. What does it mean? That means like every node is a self-referencing class or object. So it can refer to the object of same type of object which has been created from same type of class. So we have taken a class called node, and all these instance, say for example head, temp1 and temp2, if temp1 is this and temp2 is this, has been instantiated from this node class only. So in this case, head is the first class or head node, sorry, head is the first node, and this node is pointing to the second node, and second node is pointing to the third node, which is the nature of linked list. Sequential order uh, is maintained over here. Now the thing is, suppose we are having 11, 23, 99. Okay, these data are there, and we want to traverse this linked list, and by traversing we want to print the data. So our output should be 11, 23, 99. Even if we have only one node, say for example the node is having data 1 and that is grounded, so in that case we need to print data 1. Okay, so that is our expectation. Now the thing is, what is the definition of a head node of a linked list? Head node is like, this is going to be the first node. So before that, any node won't be present, and it will have, according to the linked list definition, like it will have a head pointer through which we can make any sort of action on top of this linked list. So if you want to access this linked list, you have to just provide head pointer. That's it, nothing else. Now, what is going to be the last node? The definition of last node says that it is going to point to the null. It is going to, its next pointer, or it is going to point to, it is going to be grounded. So that means it is going to be, it is going to point null, right? So that is the, and here if you, in this case, which is having only one node, the head pointer next is going to point null. Okay, so that's why this is a linked list which is having one node. So we have two cases. This is case 1 and this is case 2, which we are discussing right now. So what is the strategy? First of all, we can float this pointer into this direction. Float means what? That this pointer can start its traveling from left to right, right? Because it is not going to point, it is not having any issues. I mean, if we just say there is a pointer of node class, I'm just writing some gibberish code, but I'm trying to make it, and if I assign this, that means P is going to point over here, right? Absolutely no issues. So that means with the help, and if I do another P is equal to P dot next, then the next time P will change its location to here. Okay, so that means every time we can do, I can do like head is equal to head dot next. So if I put it in a loop and in an iteration, then what is going to happen? At the first time head pointer will be here, second time head pointer will be here, and the next time head pointer is going to point null. Fine, but is that what exactly we are expecting? Because in that case we will lose head pointer. This linked list won't be accessed. We access this linked list, we need a head pointer, right? So that's why we need a different strategy, and what that strategy is. Let's understand the strategy first. So make it black. Make it white. Take a pen. Okay. So as we have drawn, so this is our first node, this is our second node, and this is our third node. And this is a grounded last node basically. And our head pointer is present over here. This pointer is pointing to this pointer is pointing to this. We have some number and that's it. Now, if we don't want to allow this head pointer to traverse, we can do one thing. We can take a temporary pointer, right? We can make another pointer like temp, and we can say like temp is equal to, is equal to head. Then in this statement says head and temp both will point to the first node and the node which is having value 1101. So absolutely no issues. Now in the next case, we can write a while loop, right? And where we can write temp not is equal to null till temp not is equal to null, we will just try to increment temp. And before we incrementing, we would like to print line temp dot data. So it is going to print temp dot data first, and then it will increment temp pointer. So at the first time, see guys, at the first time temp is pointing to here, fine. Then temp is pointing to its value. So the value is going to be 1101. Absolutely no issues. The first output. Okay. Next, temp pointer gets incremented. That means temp location is right now here. You are doing temp.temp next. That means it is going to point the base location of this node. So whenever it is getting incremented, it is going to point its own data, temp.data. So that is going to be 22. Next one, again temp gets incremented and change this position. So temp pointer will come over here and point to the third node, which is the last node. So when he is pointing to this node, he is checking that whether it is null. No, it's not null. So it will print its own data, that is 303. And then temp pointer again gets incremented and temp pointer comes over here or here, you can say here. So when he is pointing here, he is basically pointing to null. So temp is equal to null. So this is the termination condition of this loop. So it is not going to enter into the loop. So it is not going to print anything and it will get executed. So if you just see like a simple code over here. So in this case, I have created a node class instance that is head. That's the first instance. It is having 10 value. Then I have added a new value that is 20. And then I have added 30 and 40. So 4 nodes are there. So you can see like head.next is equal to node, head.next.next is equal to node. So in the very crude way, I have added this node, which is not the right way to do that, but just for simplicity purpose, I have put my code in this way. Now I am going to call a function that is print list. Print list is taking head pointer. See, as I have mentioned, like in case of linked list, best practice is going to be we always keep the head pointer. Any sort of operation, we will allow a head pointer to do perform that operation, but make sure that head pointer will be pointing to the head node only. It won't change its own position. It won't change its position. So head pointer, see the address of head pointer, it gets stored into the current pointer. So again, in this case, the same logic we have written over here that if current not equals to null, then first we are printing the current node's data, and then we are changing the current node's position and asking current node to point to the next node, current pointer to point to the next node. So that's it. If we just run it, so it should print 10, 20, 30, 40 and see the result is there. Thank you so much. If you have any question, any doubt, please put into the comment section.